This is about one of the Morse code telegraph receivers that was used in the Crimean War. The British government laid a telegraph cable across the Black Sea to Sebastopol in 1855. They needed to control military operations, which was not possible when messages took 2 weeks to travel by steamship. Nevertheless, their generals did not obey the most important telegrams. A quick description before I show you the machine in action. It was made by Siemens and Halske in Berlin in 1852. That's early for Morse code telegraphy, which only came into use less than 10 years before. The British and the Russians both used this model, and consecutive serial numbers are split between both sides in the war. The most unusual feature is that the electromagnets that move the printing stylus are on their sides rather than vertical. Siemens claimed that this made the machine faster. It's designed to connect to a punched tape reader as input device. I want to find out if it can run at 300 letters per minute, like Siemens claimed, faster than any human could operate a Morse key. It prints the received dots and dashes with ink from that roller on the top. I need to know if this is a later modification because early machines simply scratched a mark on the paper. It uses weights to drive the motor that advances the printer tape. Increasing the weight increases the tape speed. Does this make higher speeds possible compared to a wound spring motor, like in a clock, that runs at constant speed? In this video I'll test it with 6 kilos of weights, which makes the tape move at about 1 inch per second. That's not fast enough to record 300 letters of Morse code per minute without the dots and dashes overlapping each other. In future videos I'll see how close I can get to Werner Siemens' target of 300 letters per minute. There are 2 connectors on the back for the Morse code input, and in future videos I'll explain what the other connectors on the side and the front are for. Now to the action. Here's the setup. I'm using my oldest working computer in case my primitive electronics blows it up. I'm using a 12 volt DC mains adapter connected to a breadboard which has a converter to 9 volts and a switch that can create 9 volt impulses on command from software called CW type, acting through a USB to UART bridge. The switch has to be transistorized because a relay would be too slow. At 300 letters per minute, the pulses would be down in the 20 millisecond range, which is at the optimistic end of relay performance. This software CW type is used along with the USB to UART bridge by amateur radio enthusiasts to send Morse code. You type what you want to send in this bottom window and then hit transmit. The software developer has coded his details into this preset button. Thanks, Sergey, appropriately from Novosibirsk, for so generously sharing your software. I'm going to transmit something much simpler, but first I'm going to go to this box up in the top left hand corner and reduce the speed to 60 letters per minute, only a fifth of the Telegraph's claimed maximum speed. Then I'll put the sound on to make it sound like authentic Morse and type in something more recognizable, namely SOS distress signals. Then start the motor and hit transmit. You're looking at a 166-year-old telegraph machine brought back to life. Unfortunately, the camera lost focus, but you get the message. After more tests, I realized that Werner Siemens never intended this machine to receive and print the 300 letters per minute that his tape reader could transmit. It's much too slow. On the other hand, a well-trained human operator could write down Morse code at up to 300 letters per minute if it was heard on a sounding device. It wasn't until a decade later that Professor Wheatstone developed a machine that could record dots and dashes on paper tape at up to 1,000 letters a minute. I'll show one of those machines on another video. Thanks for watching. Hit the subscribe button if you want to know more about the Crimean War telegraph machine, or check out my website for my Crimean War books. See you again.